Welcome to part 2 for applications of the first derivative. So the first derivative, remember, we talked about this in the last video, is looking at the slope of a function. And from the slope, we can determine if a function is increasing, if the slope is positive, and decreasing. That's one of the main uses. If a function is increasing or decreasing, if the slope is negative. Now there's also, because a slope is increasing, so think if you have a slope that's increasing and then decreasing, right here. Well, if I'm going up and then I'm going down, I would have a relative maximum. So that's another application. These can be used to determine if a function has a relative, remember not absolute, we'll talk about those again later on, a relative maximum and a relative minimum. In other words, they can tell us where we have a relative maximum or a relative minimum. And we can do that by looking at the change in slopes. For example, if the slope goes from increasing to decreasing, we have a relative max. So we say the slope goes from positive to negative. If we have a relative minimum, the slope is negative and then it goes to positive. Or the slope goes from a negative to a positive. This is called the first derivative test. And it is super easy to do, but you do have to show your work and justify your answer. That's the part where people don't like to do at the beginning. Alright, the test, find your critical numbers. Again, you're finding out where the slope is either equal to 0 or d and e. Set up a sign chart or a number line using the critical numbers. Now, I set up a sign chart on a number line. This is what we did that test earlier. This is that sign test that we talked about in my previous video. For each of the signs on the interval, if f prime changes from negative to positive, so if the slope goes from a negative slope to a positive slope, we have a relative minimum. So it might look something like this, or for something more, most likely it'll be smooth. We'll have a negative slope, a positive slope, and there is our minimum at the bottom. If the derivative, the slope changes from a positive slope to a negative slope, then we have a relative maximum. Positive slope, negative slope on this side, and there's our maximum in the middle. So we have a relative maximum. If there is no sign change for the derivative, then it's neither a relative minimum nor is it a maximum. It's kind of like that song, the noble Duke of York, he had 10,000 men, he marched them down the hill and he marched them up again. And when they're up, they're a max, and when they're down, they're a min, and when they're neither halfway up, they're neither a maximum or min. Yeah, you all know that song. If there is no sign change, and why don't we see that like as a cubic graph sometimes, where we have a positive slope, there is a critical number here, but there is no sign change. It's going to be neither. So let's have some fun with this. Assume that the function is differentiable for all x. And we'll come back to this in just a second. And if you come back to part 3, we'll look at the rest of the video here. Bye-bye.